In Module 2, we have seen that there are different ways to store and persist data while developing apps, especially in FlutterFlow. In this module, we will look at the most used and known database management solutions and see how you can leverage it for your application. So you will learn the difference between SQL and NoSQL database and the core concept around these two databases. Then we will look at the three known database solutions in FlutterFlow. We start with Firestore as a NoSQL database. We go to SQLite and PostgreSQL as the SQL databases. We will also look at some data mapping techniques. And we will review how working with databases can reflect on our generated code. From now on, it's time to make our app to keep information and let user to use them in different platforms and devices and even share if needed. Let's get started. Many apps require data storage and management, whether it's user data, product listing, or other type of information. When building an app, you may need to store product information or fetch and display data related to the products in an e-commerce app, or update the cart for users to access across different devices and platforms within your application. That's where databases are handy. There are two types of database management systems in FlutterFlow that you should know most about, SQL and NoSQL. First, let's talk about SQL. Consider an e-commerce app that the app needs to fetch product listings from a database to show to users. SQL queries can be used behind the scenes to retrieve all products or specific categories based on the user's request. All right, what is an SQL in this case? SQL, or a structured query language, is a standardized programming language for managing relational databases. SQL is designed to handle a structured data, where relationship between data points are clearly defined. All right, but what is a structure and what's a query and relationship? Let's get into this. Very good question. At the heart of an SQL database is its structure. Data is organized into tables, which are made up of rows and columns. For example, in a customer table, each row could represent a customer, while columns might include attributes like name, email, and phone numbers. A primary key or keys uniquely identifies each row in that table. Each of these columns can have certain data types or can have data or null. These columns are important because when you ask for data in this table, you're sure that all the rows from one table you are receiving will have all the columns. That's what we call it, a structure. An SQL database can indeed have several tables, and they may have relationships between each other. Let's take a look at relationship concept. One of the key strengths of SQL databases in their ability to manage relationships between different data sets. Imagine you have two tables, one for customers and another for orders. For example, linking users to orders can prevent errors like assigning orders to non-existing users. This connection is made using foreign keys, a column or a set of columns in one table that references the primary key of another table. That's foreign key. And this concept is going to create relationship between tables. All right, now let's connect this to the concept of a schema. A schema in SQL is like a blueprint for how your data is structured. It defines all the tables in the database, the fields within each table, and the relationships between them. Think of the schema as the rules governing how data is stored and how different pieces of data relate. Considering an e-commerce database, the schema might define tables for customers, orders, products, and order details. It would specify that the orders table is related to the customers and order details through foreign keys. This way, the schema ensures that every order is linked to a customer and contains detail about the products purchased. How does these all connected to SQL as a language? Well, a very good question. SQL is used to interact with database according to the schema. When you write an SQL query, you communicate with the database to retrieve, insert, update, or delete data within the framework defined by the schema. You can write queries to fetch the data you need to leverage in your app. For example, if we need to display the list of products after a user opens the app on the product list page, we can write a query like this to grab the necessary columns in the row of the products table. Or we need to display the product details after a user has clicked on the product card. We can write a query like this to grab all the columns in the row of the products table where the ID is equal to what the user clicked on. These are just two examples. Here is a breakdown of creating a select query to read data from the database. So as you noticed, select is the keyword for retrieving the data from the database. Once you understand how the query is structured, writing it on your own will be easier. Just to note, while reading data using select is probably happening more often, you need to add data by insert to the database with a specific column informations, updating a particular column for a specific row, or deleting data from the database. Here are some examples, but learning and understanding SQL requires more practice. There are many resources online that you can use to learn SQL, and I encourage you to take your time and learn more. While SQL is great for structured data, there are situations where flexibility can be critical concern. Imagine an app where data is constantly changing, such as social media platform with user posts, comments, and likes coming in real time, or an e-commerce app that handles large amounts of product data and needs to scale across millions of users. This is where NoSQL shines. NoSQL, which stands for Not Only SQL, refers to various database techniques designed to handle large volumes of unstructured, semi-structured, or rapidly changing data. Unlike SQL database, NoSQL databases do not rely on a fixed schema, making them more flexible in certain use cases. There are several NoSQL databases, but we will focus on Cloud Firestore in this module. Let's now explore the main concepts of NoSQL databases in the context of Firestore. Firestore's data structure consists of collections and documents. Collections are containers for documents, and documents contain fields that stores individual pieces of data. Let's consider an e-commerce app. You may have a products collection containing multiple product documents, and each document can hold product detail fields. We can compare this concept with the SQL concept as well. For example, a collection is similar to table, or documents are similar concepts to rows. The fields in each document are similar to columns. However, fields in NoSQL can vary, and they are not structured just similar to SQL databases, in which means one document in one collection may have different fields compared to another document in the same collection. That's the flexibility. In a NoSQL database like Firestore, you can organize the data flexibly and in different ways, as I just mentioned. Let's take a use case. In an e-commerce app, we can have products collection and users collection. We can design user orders information differently when the user places an order. For example, we can have an orders collection similar to products and store all orders with related information. This is what we call root level or top level collections. To know which order belongs to which user, you include additional reference fields that distinctly identify each order within this structure. Use top-level collections when you often search or filter within one collection without depending on another. For example, if you want to see all products regardless of their related orders. For instance, if you want to see all users regardless of their related orders. Instead of creating an orders top collection and storing all users' orders in one collection, we can make a nested collection called sub-collection in a user document. The advantage is that you don't need extra tags or reference fields to determine which user an order belongs to. It's already grouped. Sub-collections are best when you have several queries or filters or search on a collection based on the other collection. For example, you are loading or searching the orders of a specific user. The third way is to store the orders in the user's document as a list of orders as part of the user's fields. That's what it's called nested object. This helps when you read the user's document to access all fields, including their orders. However, there might be drawback too, since user may have many orders and orders may have many fields. Retrieving them all from one document might not be efficient. Though you can think of other use cases where the fields are not quite big and you still want to retrieve them when you retrieve the user. For example, maybe a list of addresses for a user. So deciding of each of these strategies depending on your application needs. You may have noticed that I've written a JSON-like record when I'm talking about Firestore documents, just because this is commonly used to represent a Firestore document. This format is flexible and easy to read, making it perfect for handling unstructured data across various use cases. These fields in document can have various data types, leading me to talk about data types in Firestore. Firestore supports multiple data types, some of which we already know and some specific to Firestore itself. These include arrays, booleans, strings, maps, geographical points, null, and document references. Now, the question is, if you have created collections and documents with proper fields, how do you access the data from Firestore? For example, when you add orders to a user in their sub-collections document, you want to show them in the app. You need to access their data and read and display the orders. Or when you want to show the product details in the product details page, how can you access the product fields from a specific product document and display them in an app? When you want to read and write data for the examples I mentioned, you need to think of a path representing the hierarchical structure of your collections and documents. For example, I mentioned a collection named users. Each user document contains a sub-collection called orders. You can access a user's orders using a path like this. Or when you need product details, you can access them via a path like this. After knowing this, you can programmatically perform necessary actions. In FlutterFlow, you can use different ways to do that, either using actions or backend query, which we're going to talk about it in the next video. Understanding this path is particularly important when performing actions and writing security rules. We will deep dive into that in this module. And one last thing about NoSQL concept. You can always perform different actions such as read to retrieve the data, query to make more complex reading from data, filtering or search, create to add data, update to modify a specific document, and delete to delete the specific collection or document. And one last thing about the Firestore concept or NoSQL in general. You also have different actions to perform, such as read and query. Queries are like search and filters, which also helps you to retrieve data from a collection or multiple collections. You also have create, update, and delete to work with your documents. And in the upcoming video, you will see that how FlutterFlow is helping you for all of these actions as easy as possible in the app builder dashboard. Okay, so that now you know about the core concept around databases, let's discuss the specific types of database connections available in FlutterFlow. We will start with Firestore. To start with Firestore, you need to do three things. First, you need to define your top-level collections. Then, you need to define a schema, or in other words, create fields and define the data types of those fields. And then, you need to define rules and permissions. So I want to give you one tip here is that you can also create sub-collections in a step one, but I recommend starting with top collections and document fields and then defining sub-collection. Let's see how it works with details. As we have seen, a collection is a group of documents. For example, you could have products collection that contains a list of documents, each representing a single product. You can access the Firestore tab in the navigation toolbar in FlutterFlow. Then you can select creating a collection. Keep in mind that the collection name is gonna exactly appear in Firestore. We will see that shortly, and needs to exactly match what you already have in Firestore if you already have an existing project. Once you create a collection, you can define your document fields and a schema. You may be able to use a predefined template or use generative AI to create schemas for you. If none of which works for you, you may use it from scratch to create your own custom schema. The next step is to define fields and their data types. Luckily, FlutterFlow provides an easy behind-the-scenes data type conversion. So you just need to make sure what you see in FlutterFlow matches your needs. For example, a price can be a double. Once you're done, ensures that you click on check marks to add the field to the list. Let me quickly remind you that the document will look like a JSON object, which we have already seen in previous video. This is how JSON maps to fields, which is handled by FlutterFlow. If you decide to have a sub-collection, you can repeat the process of adding collection by choosing this is sub-collection option. If you want to track changes in product, you can create logs under products. Each document will have a subcollection named logs. Creating fields for logs collection will be the same. Let's see what it looks like so far overall. Products collection with product document fields where each document will have logs subcollection and logs collection will have defined fields in each log document. All right, now that you have a better picture, let's see how these will appear in Firebase. We have seen in Module 14 how you can navigate to different products in the Firebase console. When you open Firestore, what you see is a representation of what we have created so far. Fantastic, but now we have created a structure we need to handle permission. Letting everyone with any permission, like read or write to our database, is not secure. That's where Firestore security rules come in. In Module 14, we learned a lot about security rules. If you want a refresher, please check them out again. But let's now see how you can apply security rules to Firestore. You can use Firestore setting available inside FlutterFlow under Firestore settings to set up basic rules. The security rules table in FlutterFlow makes it easy to create rules without writing rules in many use cases. And it includes all operations like create, read, write, and delete. For example, you may assign everyone on read operation on products collection, which means everyone logged in or not logged in, or authenticated or not authenticated can read the product documents. However, you may restrict writing or deleting these documents to only logged in user. You can also assign a specific permission to authenticated user. Imagine we have a card collections to store users' card and persist data for them. You may add a document reference to the card document field user ID to see which users owns this record. One benefit is that you can restrict access writing to these documents by other users. This means now you can restrict accessing this card by tagged user, which is user ID as a document reference to the user's collection ID. What happens is when the user login, it will have a user ID. It is the same as the user's collection document ID. And then a card document can only be created by this user. This can be even more interesting when you have sub-collections. Imagine you have logs sub-collection, which is under a user document identified by a unique ID. To ensure no one except this user or certain users can write to this collection, you can use a tagged user and select the UID you have defined in the user collections. In this case, only the user who is logged in and the user's ID matches the parent user document UID can write to this collection. These rules are very important for securing your database, so always pay more attention and make extra effort to fine-tune them. And lastly, when you make any changes to security rules, you should ensure that is deployed and published. Before you can deploy the rule, you may be asked to review your changes. Here, you can check the differences between the before and after versions of the Firestore security rules, and if all good, then deploy. The rules will appear under rules in the Cloud Firestore dashboard. Notice that you have a history of deployment. This means that you can always come back to a previous time and revert your changes. Pretty practically, if you made mistakes or did something that was not supposed to be deployed, you can use this feature. Before the demo, I want to share one more thing with you. The FlutterFlow dashboard for writing and managing Firestore rules are great, especially when you have simple structure for rules. But if you want to write more advanced and complex rules, remember that you can always directly handle them outside of FlutterFlow, just like what we did in Module 14 with Firebase storage security rules in the Firebase dashboard. Imagine in this example here that I have defined more complex rules. Just look at this example. So that I have defined function, I wrote and used this function in my rules. If you just follow the numbers 1, 2, 3, 4, 5, 6, 7, you see that these rules are more complex compared to what you can do in FlutterFlow. Once you made these changes in Firebase console, make sure you publish your changes. All right, the schema is defined and the database is secure. Next is add some content. You can either go to Firestore and add data, programmatically add data, or use Firestore Data Manager in FlutterFlow to add data to your collections. Apart from users collection, where it's not recommended to modify the data, you can manage, edit, add, update data from the rest of the collections, either by uploading a CSV file, which helps you upload multiple documents at once, or by adding documents one by one. You can create, update CSV files with Microsoft Excel or Google Sheet. Keep in mind, some of the documents may not have any document, and you may add the document dynamically when the user is interacting with your app. For example, adding a product to a cart or placing an orders for a user. But how can you now use these data? There are two different ways that you can do this in FlutterFlow. You can trigger related actions such as retrieving the data on page load, or creating, updating, or deleting the document when a user interacts with your app. For example, tabbing on a button. You can also use backend query, which can be set on a particular widget or an entire page. Backend query helps you to trigger a query automatically when a user navigates to the page containing the query. The information retrieved using the backend query can be used in any widget. When you select a backend query, you will have multiple options, including query collections, which is used to fetch a single record, or a list of records from a Firestore collection, and the document from reference, which is used to retrieve the details from a document reference in Firestore. For example, if you already have a reference for a document like a product ID, you can use document from reference and get the details of the document. In the query collection, you have at least two essential steps. Select the collections that you want to query upon. Define an action whether you want all documents, just a single document you already have the ID, or just a total number of document or count. You may want to filter your content based on different fields of the collection and their values, either with an or and operation. You can add multiple filters. The difference is that or filter will match only when one of the filters is true, while the AND operation require all filters to be true. Next, if you want to order your data in the query, you can select any field from the document fields and choose if you wish to order by increasing or decreasing the value. It is important to keep in mind that Firestore queries in FlutterFlow are all streams, which means they are real-time. Any change in a collection or document will be reflected on the app for a certain query almost immediately. If you don't want this option, you can check the single time query box to query only once and not refresh on updates. We will see in the generated code that this is going to be reflected as future instead of a stream. By default, if the value of any filter is empty, the query will still attempt to find documents. Checking the ignore empty filter values box will instead ignore empty fields. And lastly, by default, if the value of any filter is null, the query will ignore the filter for that field. Checking the filter on null values box will instead keeping null filters. Remember, after adding the query, you need to bind the data to an element that we want to show the value. That's where you can find collections name documents. For example, products documents. And then you can map what document property is supposed to be binded for that element. You can also have several actions for Firestore in case you need to do that during an action like tabbing on a button to load data from a collection. As I mentioned, you also have several actions for Firestore. In create document action, you need to select the collection for which you want to create a document and then set the fields either by custom value or from variables, such as a widget state. By default, documents are added with an auto-generated ID. However, if you prefer to use your ID for the document, you can enable the custom ID toggled. An example here would be when you want to create a cart document under the carts collection. The ID of the cart could be the ID of the user, which in this case, you can immediately access to the user cart by knowing the user ID. Or another example would be when you want to place an order. There are multiple orders that you may want to place in the user orders sub-collection. So in this case, the ID of the orders can be auto-generated. In the update, delete, and read document, if you require a specific document, you must select a reference for that document. This reference can be passed differently, such as by page parameter. For example, when you are going to a product detail, you can have the product ID on the product detail, which in this case could be the document reference as the product ID. Here's another example. In my user document, I have defined a cart reference field where I can now select it from authenticated user variables. Also keep in mind, if the action returns a value, give it a variable name. Later in this action flow or somewhere else, this variable will be accessible under the action output. Beautiful. These are all of the concepts that you need to work with Firestore. And now we need to go and see them in a quick demo. Here is my application. And what we've done so far, we had this button, floating button. If I take a look at the flow action, we see that we are updating our state to add a product to our app state products. And then we've been reading that app state. If I go to the generate dynamic children and then add it to the products list, when this list view was showing these products. And then we could also pass the ID from this product ID and go to the product details. So here is my product ID parameter for this page. So what we're going to do right now, this is a perfect scenario to replace it with data from Firestore. And to demonstrate, we're going to have create and then read as well as query. So what we're going to do right now, we're going to go on the Firestore tab and start creating our schema. We do not have anything as of now. So let me just go ahead and show you the Firestore dashboard in Firebase. For the first time when you come to Firebase Cloud Firestore, so you can find it under build menu, you find also nothing here. That's where you can define your schema. So you can start by creating a collection, for example, products. And you can also go ahead and generate document, either custom or let it be automatically done, and give it a field, for example, name, and also different data types. So what we're going to do right now, I'm not going to use this Explorer. I'm going to use FlutterFlow in this case. Let's go back to FlutterFlow and create our schema. Okay, so let's start with products as of now. Just make it simpler. So I'm going to start with products. And in my products, I will have a schema. So I can do in different ways, generate with AI, Scratch, or using a template collection. I think I can actually use products templates collection in this case, or probably using from scratch, but let's go and use the product templates. Beautiful. So these are the fields that maybe some of them we need at the moment: name, description, and so on and so forth. So I'm going to delete this and then again create from scratch. We need a title, and that's going to be a string. We need a description, which is going to be a string, and a price, which is a double. List of images, and sizes, which is a list of enum of product sizes. So we already defined our product sizes in custom data type. Let's quickly check that. And here is our enum. You can use your custom data type that you are creating. All right, that's good enough. I'm going to go and add one product to this. To do that, I'm going to use Manage Content button here. For the first time you come, of course, there's no document. You can upload all of your documents based on the fields that you have, or add it manually. I will go ahead and add manually one product as of now. You need to just fill all the description with proper field type, or also randomly you can pass some pictures as well as product sizes. Let's select only 2 in this case. And that's good. Let's just add. Beautiful. Now we have a document here. But how does this look in Firestore right now? Let's go back to Firebase dashboard. This time, when I load the Cloud Firestore Explorer, you see that the collection is appearing here, and I have one document created, which has the fields that we just created together. Beautiful. As you can see, you can even have nested collection here. Like, for example, logs for the products. If you want to track who is doing what on this product, you can maybe create a collection and add all of your logs. All right, so I'm not going to do this right now. Here, I will go back to set the rules. All right, I will go back to FlutterFlow. The next thing we need to do, we need to go to the Firestore setting and make sure our schema has proper rules. I'm going to go to Firestore rules here, and you see that I only have one collection at the moment. Let's protect. So we just want people who are logged in to randomly create product. Of course, it's not a real scenario, but it's just demonstrated how you can protect. Let's say I want to just authenticated user do that. And look at this match here right now. It added the request.auth to not equal to null. And that means only people who are authenticated can create product under this collection. Who can read? Everyone. And I will continue doing the rest, like write and delete. No one can do that. All right, so now I need to deploy these rules. Let's go ahead and deploy that. And now it shows me that we are going to add these new rules for the products collection. Beautiful. Let's go and deploy that right now. All right, that's deployed. Let me show you how it will appear in Firestore dashboard. If you go to the Rules tab right now, then you see that what we have defined there is automatically appearing here. As we have done for Firebase storage, let me just quickly show you the rules there. We already have managed that here. We can do that also for Firestore. And if you already get familiar with Firestore rules and security rules, I would encourage you to maybe keep everything here, which makes you more flexible. There's one rule that here you may notice is that read and write if the request email matches Firebase at flutterflow.io. And that's where you can manage your content and you can create the data. All right, beautiful. That's it. Let's go back now to our application. I will make one more change just to demonstrate. So I'm going to change the write to authenticated user as well, and to delete to no one. Let's see how it will appear right now. And as you can see right now, the change is also showing you in the deploy rules diff panel. So that looks good. I'm going to go deploy now and deploy it. Beautiful. So there is one thing that you can do here. You can also use the users collection in case you want to add extra information for user or keep the users there. So we don't have the collection. Let me just go ahead and quickly create that. And as you can see, FlutterFlow is already telling me that if you like to pre-populate the default user field, and I say yes. If you want to add more field to the default ones, go ahead and do that here. Going back to settings, now I have my users collection assigned here. Beautiful. So that's very good because then every time I want to, let's say, add to cart or place an order under a sub collection of a user, which we can actually create right now. Let's do that. Orders, a sub collection of users. Then in this case, we can get a reference of user document easily. All right, that's good. Let's go ahead and add the actions right now. So the floating action here we had adding the data to the app state. Let's now go ahead and fix our queries. First thing first, we're going to load a list of products. We already have done that with generated dynamic variables from app state. I'm going to remove that and I'll go to add query. That's a backend query that we can add to this widget. And this time I can select query collection. In the query collection, you can say, which one do you want? And I can say products. Beautiful. Which type of query you want to do? Is it a single document? If you already know the document ID, is it like the total you want? For example, it would be very nice for number of orders, or a list of documents. I say list of document and please give me like 10. And you can actually query that right now. You can filter by different criteria, like different field and with and or. I will not have that here, but I can say maybe order it with the price if they are decreasing. Okay. So, and in this case, as you can see, it says single time query enabled. I will just turn this off because I want to listen to the changes of the products. And every time you're adding one, it automatically gets added to this list. Beautiful. That's going to be in a stream of products. Confirm. All right. Now that we've done that, we need to fix these title price that we are passing to the product item card. Select the product item card and go to the component property. And you see that they are already unknown because we removed the previous actions. I will now go and select these values from variables. And you see now this time we have products document. Beautiful. Open that and then you have full list of document fields and even some helpers, like in case the field has title or price and so on. It would be very nice to use this when you want to do some conditional, expressions. I'm going to go and use the reference. The product reference is the unique ID in this case. Let's do that. For the ID of the product, I will repeat the same. So the reference is going to be the document ID, as you can see. So the title is going to be title, price, product document price, and lastly, the images, products, list of images. And I want to do the item at the index and Maybe only the first one. Beautiful. So next thing we want to do is we want to make sure this floating action now add the product to the Firestore. So far we are reading the data, we have not added anything. So if I load the application right now, we only get one product because we already added to our collection. Let's fix the floating button action. I'm going to go to the action flow editor. Let's remove the app state and add a new action on tab. And if you search this time for Firestore, you will find multiple actions. And what we really want to do right now is create document. Let's go and create a document. Select the collection that you want to add this document to. And now we need to just set the fields. So let's do that. We're going to do that randomly right now. So for title, for example, I'm going to set that from random variable. I will go to my sample data and I will just give it a name. Let's say only first name. Let's repeat that for description. For description, let's just write random text description here. Let's do a price. I will do that from variable, and I will just do that actually random data. And that's going to be a random double between possibly $100 to maybe $500. And then images, which I can also do random values from random or sample data, list of images. Beautiful. So we do also have sizes. Let me just go and add a size and set a value. And let's just add all the sizes for all products. I don't want to set a custom ID for my product. It's all good if it's auto-generated. And I also don't need to get an output variable to use it later, which is all good. Keep in mind now, this is going to create a document over internet in Firestore. So if your app does not have access to internet or it's offline, this may not work. So in this case, it would be nice to have some kind of app state or state in the app to show to user and maybe take some action later when the internet is back. But don't worry about that. For now, we keep this as this. All right, there's two more issues I see here. Let's go ahead and fix that. First, parameters product ID passed by product ID card. So this one has a problem. And that's because when we navigate to product detail, we're passing the product ID. And that is not known right now. So we need to go and say, this is going to be from products document and the reference of the product, which is a document ID. Beautiful. We are navigating now to product details with the product ID reference, the Firestore document. All right, I see now we have one more error, and that's because we created order sub-collection, but we created no schema. So let's go ahead and create quickly one field, maybe in this case, created at. All right, the error is now gone, but we have two warnings. So let's take a look at the warnings. We added collection, but we forgot to add the rules. And this is very important when you are working with Firestore. Let's go back and now pay attention to our collection. And as you can see right now, the users collection already get the users collection. So the users can deal with all of these permissions, although I don't want anyone to delete anything. And the same for orders. I don't want anyone to remove the orders. So I'm just going to make the delete all none. And order sub-collection, though in this case, you will see have access only users for that collection. Let's take a look at the rules. And as you can see here, it says the users order sub-collection document will get only access to the users. The parent here is going to be the user ID to the UID of the request that is coming. Like when I send a request, I want to add an order to this collection, orders. I'm going to have an ID as a user. And that needs to be same as document ID of the user. All right, that's perfect. So let's go ahead and deploy this. We see the changes, all green. So far, so good. Deploy. All right, there is one more problem here that I would like to talk about, and that's going to be the private sensitive data. And when you have this checked for a collection, you will get these warning. So, and in case you have the read open to everyone. If this product has sensitive data, you should not have the open read to everyone. That should be at least authenticated user. But for example, for products in this case, we don't really have sensitive data. We want actually everyone to read the product's details. So therefore, I'm going to go and disable this. And voila, now there is no issue for the product. Let's go back and check and test our application. I'm going to use my FlutterFlow desktop app and I will restart my application in my simulator. Then let's go ahead and log in. There we go. And beautiful. We only have one product here, as you can see. And that's very nice. It's just because we added one product to the Firestore products collection. So if I now go and add one more, that is appearing quickly here. It's super fast. One more and one more. Beautiful. So these are all nice and beautiful. So let me just go back to Firestore dashboard. And if I now go to the data, you'll see that under products, now we have 4 different product IDs. And the interesting part is that these products are actually sorted by the price. You see that the biggest number is coming first, even though it might not be added as like the first product. All right, now when I click on this product, it should go to the product detail. We need to also fix that to read from Firestore. All right, I'm coming back to my app. And so far we added the backend query for list view for one element. So I'm just gonna go to my product detail page. And then this time I see that when I come to this page, I need to get the data, right? And that's where the backend query comes in handy. So I'm just going to go and add a backend query. And this time I want to get it from a reference. I know my reference right now. If I select that, it's going to be the products and the reference is going to be the product ID. So the type is not correct because we need to fix this type before we can use it for the reference as a document. So I'm going to go and just select it as a document reference from the products collection. Beautiful. So if I go back to my product list, and you will see that on the product item, let's go to action. When we are passing the parameters to the page, we need to pass the document ID as the reference. Beautiful. That's now working. So let's go back to product details. All right, now we can go and add our query. So let's now get the document from reference. And that document is in the collection of products. And that is our page parameters, product ID, product reference. Beautiful. Confirm. And I still can keep it as a stream of data. If any changes happen, I can get that in real time, nearly real time. Or if it's not needed, you can just say single time query, but I'll keep it as real time for now. So now let's fix the variables here. All right, let's go and change the title. We don't need the app state. It's a products document title. The description is gonna be the products document title. And I need to fix the price in this case. Let's go and fix the price as well. I can format my price, let's say with decimal, and change the type as automatic based on country. And I will also add a currency as dollar symbol. Beautiful. Let's confirm. And the pictures needs to also be fixed. Let me just go back to the images. And here's the path I will just change the path from the products document, list of images. I get it from item at index, and we just need actually the first one. Confirm. Beautiful. It should be good to go right now. Let's go ahead and test it out. All right, I'm gonna reload my app. And there you go, here's the product. Let's click on this. Beautiful. Now we have the image, description, and all the other information that we needed. And even our animation is working as expected. Very nice. Just to mention, this list on the button is though reading still from app state. So that's good. That was all about the Firestore and how you can work with Firestore.